about our case study, subject Building Technology for DBT244. Our topic is ship pile. The location project is at Lumut Maritime Terminal 2 in Batu Udang Segari, Manjung, Perak. Next, I will present our group mate. First one is Raja Atta, second one is Nur Hazwani, third one is me, Nur Azza, and lastly Adriana Masturina.
My name is Adriana and I will be explaining on how ship pile works. So ship piles are long interlocking sections made of steel, vinyl or concrete used to retain soil or water, especially in tight or deep excavation areas. Driven vertically into the ground, they form a continuous barrier to support excavations, prevent soil movement and control groundwater. They are commonly used in waterfronts, basement, bridge, abutments and flood defences. Ship piles are quick to install, space efficient and often reusable, making them a sustainable option. Their interlocking design improves strength and water resistance. However, they work best in cohesive soils and are less effective in rocky ground. Despite some limitation, ship piles are essential for efficient earth expansion and complex construction.
For this case study at Lumut Maritime Terminal 2, there are three main objectives. First, we want to identify the type of ship pile used for this project. Second, we aim to investigate the method of installation. Lastly, we will identify the problem faced during the ship pile work and explain the solution used to overcome these challenges to keep this project safe and on track. Through this objective, this study shows how proper planning and execution help ensure successful ship pile work for a big marine project like Lumut Maritime Terminal 2. This project is the expansion of Lumut Maritime Terminal at Mukim Lumut, Manjung, Perak. The client is Lumut Maritime Terminal Sdn Bhd, which is operate Lumut Port. Phase 2A, including building onshore and offshore facilities, including a new open-type raft to handle more cargo and support growing industrial and maritime needs. Key consultants are Arsia Consulting Engineering for civil and structure work, Mega Jati Consultant for M&E, and Pakatan Ukur Bahan as the quantity surveyor. Muhibah Engineering is the main contractor. With approval from Majlis Perbandaran Manjung, construction started on 21 November 2023 and is expected to finish by 21 July 2025. When done, this project will strengthen Lumut Port as an important maritime gateway and boost the local economy. This slide shows the location of our case study, which is at Lumut Maritime Terminal 2 or LMT2. The site is located in Mukim Lumut, Manjung District, Perak, inside the Lumut Port Industrial Park. The terminal will develop in 3 phases on 90-acre site. As shown in the location plan, the project site is the next to Dinding Bypass. The surrounding area include an industrial zone, which is Malaya Flour Mills, Bainon Bridge, the Manjung River, residential area and the nearby forest. The location is also close to Segari and Setiawan. This location was chosen because it supports the port expansion needs and is well connected to key industrial and transportation links.
The main aim of this project is to expand Lumut Port's capacity and efficiency and to become the top bulk cargo terminal in Southeast Asia. There are several specific goals which include handling up to 7 million tons of cargo every year, allowing large ships up to 50,000 tons with a 12-meter draft, building a new main raft with a modern system, carrying out dredging to deepen the water, creating 500 new job opportunities. Next is supporting local suppliers and businesses. Next is protecting the environment and following all standards. And finally, supporting the Perak Sejahtera 2030 vision and global trade needs. This study focused on the ship pile works at Lumut Maritime Terminal 2 located in Batu Udang Segari, Manjung. There are 3 main objectives in the case study. First, to identify the type of ship pile used. Second is to explain how the ship piles were installed. Third is to find out the problem faced during the project and how they were solved. We also look at the ship pile type, design and materials and why it was chosen. We explain the installation process including site preparation, the equipment used and safety checks. Finally, we studied problems such as soil condition, tides, and equipment limits, and how the team handled these challenges to ensure safe and successful construction.
This case study focused on the ship pile work at Lumut Maritime Terminal 2 LMT2 located at Batu Udan Segari in Manjung Perak. LMT2 is an expansion project by Lumut Maritime Terminal Sdn Bhd with a total cost of RM282 million. The purpose of this project is to increase cargo handling capacity and improve port operation to meet the growing industrial and maritime demands in the area. The project is divided into three main phases, which is land acquisition and site preparation, rigging and the construction of onshore and offshore structure, and finally the terminal developed with a new wharf and related equipment. For this project, steel sheet piles are used. Temporary sheet piles support the ground during excavation and dragging work and are removed or reused once the work is done. Permanent sheet piles remain in place as retaining and quay wall to hold back soil and water, ensuring the wharf structure stays strong and safe for port operation.
For this project, the type of sheet pile used is the Z-type OZ45700 made of steel. This type was chosen because it is very strong, durable and perfect for marine construction. The sheet pile have a Z shape profile that give high bending resistance, meaning they are strong enough to hold back soil and water pressure. They also lock together to form a continuous and watertight wall, which is very important for deep excavation and permanent structure near water like quay wall and wharf. There are several reasons why OZ45700 was chosen for this project. First, it is strong but lightweight, making it easy to handle and install on site. Next, it has a tight interlocking system that forms a secure and watertight wall. Next, it is made from corrosion-resistant steel like ASTM AC19 or S355 JOC, which is good for seawater conditions. Next, it is quick to install because each pipe is 700 mm wide, so fewer pipes are needed. Lastly, it can support heavy loads such as large equipment and building structure while staying straight and stable underground.
Now, I'm going to present about method of installation of sheet pile in our case study. So, the installation of sheet piles is a crucial phase in jetty development. It requires a careful planning, specialized equipment, and proper sequence. It depending on whether to use in temporary or permanent. The process may vary slightly, but the key steps are similar. So in this case study, it used a two type of sheet piles. It has permanent, become part of the final jetty structure, and the second is temporary, used for dry working space during construction. Firstly, let's go through the permanent use of sheet pile installation. First step are prepare site. Clear the area and mark where piles will go, and then set up guide frame to keep piles straight. Second step are position piles. Use a crane to lift and place each pile. Make sure it fits in the guide frame. And the third is drive piles. Use a vibro hammer to push piles into the ground and then pre-drill if the soil is very hard. So for the next installation is we need to check the alignment. Check that piles stay straight and level. Adjust if needed. And the fifth part is to connect the piles. Lock piles together to form a strong wall. And last step are quality and safety. We need to check depth and position, and then follow safety step and design standard. Now I'm going to talk about the temporary use of sheet piles installation. First step we need to prepare site clear and mark where piles will go. Second is install guide frame to set up a frame to keep piles straight. And the third step is we need to place piles. Use a crane to lift and position piles. Next steps are draft piles. It uses vibro hammer or drop hammer to draft piles and then pre-drill if soil is hard. Next, we need to check the alignment. Make sure to check a piles to stay straight, adjust if needed. And then, it supports works. Piles can hold soil and water back during excavation. And then, for the next part, we need to remove piles. We can pull the piles out when the work is done, and then we can reuse the piles if needed. And lastly, we need to follow the safety and checks. We need to inspect for stability, and then we need to follow the safety rules during work and removal.
Next, the problem and solution of using sheet pile. This slide shows a SWOT analysis, which is mean looking at strength, weakness, opportunities, and threats. First, the strength. Sheet pile are strong and long-lasting, especially in marine area. They are easy to install and remove, and they help control soil and water safely. Also, this method is common, so many workers are already familiar with it. Next, the weakness. Sheet pile can make a lot of noise and vibration. They are also hard to use in tough soil and might go out of line. To do the work well, we need skilled workers and the right machines. Now, for the opportunities, using sheet pile can help finish project faster, and it also help train local workers. New technology can reduce noise and vibration, and using them can give a better, greener image to pots. Lastly, the threats. Sometimes soil problem can delay work. Weather and tides may also stop progress. People living nearby might complain about the noise, and we must follow strict environment rules. Next, the solution. We solve sheet pile problem in several ways. First, we did better soil checks by studying the ground and choosing the right pile size and types. Then, we used the right equipment like heavy vibro hammer and pre-drilling along with guide frame to keep the pile straight. Good planning was also important. We worked during low tide and used confident and pumps to keep the site dry. To make sure everything was correct, we used template and checked the depth and position of piles often. Lastly, to reduce noise and vibration, we monitor it carefully and use quitter method in sensitive area.
In conclusion, the sheet pile installation at remote port has proven to be an effective solution for retention and waterfront stability. The use of steel sheet piles has helped secure that port's foundation against soil movement and water erosion, ensuring the safety during construction and long-term durability. The project demonstrated efficient construction practices with minimal disturbance to surrounding operations and the environment. The interlocking system of the sheet piles provided a strong structural support and allowed for quick installation, which helped keep the project on schedule. Overall, the sheet piles system at the port successfully met both engineering and environmental requirements. It serves as a practical example of how sheet piling can enhance port infrastructure while maintaining safety, stability, and cost efficiency.